It's still
We're
starting.
back.
Okay, there you go.
Laura, where are you? We even needed your input the last over half of the semester.
Yeah, so the prep assignment P. Like I get that P hat is your population proportion.
Yeah,
It's the hat.
Yeah. Is that what he calls it?
P hat. Yeah.
Mhm.
That's proportion. I think P by itself is a proportion
Population.
or something like that.
That's what I thought it was. I'm gonna look it up.
But what's the difference between the two? Because like a proportion for the population is just how many are included.
So, give an example. Yeah, explain which variable stands for. So P hat is represented by the letter P or the population proportion or the population total.
So what's P by itself?
It's how many.
Is P by itself is there a P by itself?
Yeah, it's how.
Which is the mean of the distribution of P.
Yeah.
Thanks for clarifying.
Whatever that means.
That
It's
helps.
very helpful.
The true population proportion, and then you have the false population proportion for the P hat. That's why they wear hats.
Now we're gonna remember that for the exam.
That'll be an actual question. Which one's this?
Why does the P wear a hat?
It's cold outside.
Well, because P hat population proportional. Because we the formula, so like P hat equals P, which is like the 0.07 in that problem, which the 0.07.
It's kind of well, the 0.07 is the true population proportion.
It's the true unknown percent of the population that do not have, in this case.
It's the true population proportion, and then the other one is it's
The true insignificant to say true though. The true unknown.
I have no idea. I had looked through all of the videos and I thought I understood stuff, but I was wrong.
I thought I understood everything going to that exam.
Yeah,
I was just like,
apparently not. That's what we get assignments without Bruce.
Well, I know I was like 2 hours away. Like literally, if I had 2 more hours, I would have like. I really think I could have nailed it, but
you have actually spent 4 hours.
Studied for 2 more, and then I would have taken the exam.
Oh.
I was like,
Well, technically, it's 4 hours that they give me. Yeah, I think I spent like 45 minutes.
It's like the first one. I honestly didn't really study. I got 90. This one I like studied more.
Worst score. Yeah,
No,
same
worst.
thing. Great. That's how you should do
I
it.
actually did 2 grades.
Never do it again.
Yeah, 2 during like.
They lied to you.
Okay, so P is the population proportion, the true population proportion. I guess maybe as we take the quiz, like some of these things become more clear as you use it, but yeah, at least you know the. So that's the formula. Really get what it's actually calculating, like why that's different. Is this like calculating categorical something?
Yeah, it's categorical data. So what is you can't what he said in the video is if you can use arithmetic with it, then it's quantitative, right? But if you can't, then it's categorical. So for example, like they were saying, what was the question again? How many are this thing. They're not asking. Anyway, it's categorical. It's not numbers that they're looking for. They're looking for just like a thing. I don't know. It's confusing actually.
Yeah.
We should just do that like for our assignment, categorical.
Yeah,
Let's just do like the easiest test ever.
I agree.
How many legs does a chair have?
Can we do a flipping coin? That has always interested me. Just
How
kidding.
many tires does the normal car have? Well, 100.
The average American car. As you can see, it's not a normal
No,
distribution.
actually, these days there's a couple that have some weird, like
Yeah,
3.
so hey, we might get some.
I might just skew it a little bit.
All the 65, 95. How many is there? Is it 60, 90, 95, 99?
65, 95, 99.7.
Yeah, just 3.
Okay.
All
That's what it came down to on the exams. Like, is this one standard deviation away or it's 2? But I couldn't remember what the numbers
For that part. All right. Should we do it?
Yeah, I guess so.
All right. So, this
I don't know.
can't touch it down.
Like, I'm just rapping that all
Really?
the time.
That
Stop collaborating.
you were required. If needed, here's a link to the normal probability. The pie chart. Why are slices different sizes? The size of each slice is random. Yes.
It's all true.
I don't know. I think I was gonna go with the last one, but I think I'll just do the third one instead.
Quiz stuff on here. Like, I don't see why they don't give you like the full screen or something.
I know it's
Because like
annoying.
especially on a laptop, it's like
Oh, I hate it when it's your frickin' A.
it's like and there's no
Our
other.
bar charts and
Okay, I completed it.
what charts? What the frick is up? Hey,
It's nice to get these points again. I actively participated in this week's group meeting.
ugh. Do you guys know what a Pareto chart is?
Yeah, that's in the chapter.
Oh, well, that's nice. I didn't
Let me see.
actually.
the third one, the Pareto or whatever goes down.
The only difference is the bar chart is down. Sure.
You ready for the definition? A Pareto chart is a bar chart where the bars are presented in descending.
We concluded that p hat is normally distributed if
Yes.
In a pie chart, why are the slices different sizes?
what? Yeah,
It's
yeah,
the
it's-
proportions.
yeah, it's the proportion.
How are bar charts and Plato charts
It's
related?
the
Plato
last
charts
one.
went several times.
Is p the true proportion or the sample? See, that's what it is. The true proportion and p hat is the sample proportion. That's what the difference is.
But the sample proportion is just like
It's just like the proportion mean. It's the same thing. But
why did they
you're
pick P?
for proportion?
Okay, there we go. BP and TP or like total proportion. Just kidding, I don't know.
No, they got to make it complicated.
But I guess okay, I guess with proportion P isn't.
Well, let's just remember that the hat is like represents it's like a crown of
A crown of
what is n is the sample size.
if P equals 1/4, what is the smallest n that satisfies the requirement? What requirement?
What requirement? I am so confused. I don't have it. P equals 1/4. What is the smallest n that satisfies the requirement? The smallest n would be 4.
Why?
Well, okay, so as far as I understand, P equals x over n, right? So P equals X 1 over 4. And as far as I understand, when it comes to fractions, they just ask you to simplify it as small as it could go when it comes to proportion.
But what's the requirement? Like, what is it? What is it like?
Wait, so wouldn't that be like, it's literally saying P.
Well, they're saying what is the smallest n?
And then
So you see that the equation is X over n.
yeah, so
one
the n is
The only thing that makes sense to me is that the requirement is you can't get any smaller than 1/4. If it was 36 over whatever, you could make it to the smallest requirement. So it would be 4.
yeah, I think that makes sense. I'm just gonna look up if they
Yeah,
have
go for it.
It's not even in the chapter.
What is the mean of deviation? Where's my mean?
Suppose that n equals 24.
P equals 4. Where is the mean there? So it's P. So 0.4 times 1 minus 0.4.
That's the formula for
Yep.
mean.
Mm-hmm. P minus 1. P times 1 minus P divided by n.
This is for standard deviation.
No, this is for mean. Standard deviation is different. They'll probably ask us to find the standard deviation here pretty soon, but that's not what we're finding right now. So
The mean of the sample proportion P is normally distributed if n is large. The true population mean is a random variable. See, look at this right here though. It's a pretty simple equation. Equals P. And then this is the standard deviation equation right there.
mean of P hat equals P.
Yeah.
That doesn't make any sense. So you're saying if I was to do the regular equation, it would just equal 0.4?
Well, like what regular equation? Like this equation is the standard deviation, and the mean of P hat equals P. So like if you know P, then you know the mean of P hat.
So it's literally just 0.4.
Yeah, at least as far as 3.2.2 says.
Okay.
According to section.
That's weird. Because in the homework, he did that equation.
Well, but that's what we're gonna do for question 9 is P hat.
Oh, yeah.
Well, but this is mean and this is standard deviation.
Yeah, but this is as the standard deviation of P hat equals this right here. So I'm assuming that's what we.
Yeah, the only difference is I didn't do a square. He didn't have us do a square root. But yeah, I mean, I don't care.
He just didn't finish the problem on the video. I don't think.
But I don't know. I don't care. If you think you're right, I really don't care. If it's right, then it is. Care less. All right.
0.4.
0.01.
Oh,
Square root.
I have done that.
Point one.
What is n? You got 0.1, 2.
I didn't expand.
Round to the 10th place.
So it's 0.13.
Wait, isn't the 10th place just one decimal?
0.1.
Yeah.
Yeah. I think, right? Yeah. Yeah.
Yeah. All right. What is P hat? So I just don't believe that they would keep asking us what P hat is if it was literally.
Well, it's only the mean.
That's the mean.
Oh, okay. That doesn't make sense. Well, I don't care. What's P hat? The equation. I'm on p hat.
X divided by.
Yeah, that's right. But x would be the 35 hits internet.
X is the number of individuals in sample with the characteristic you're focusing on.
Oh.
No, x is what?
Number of individuals in sample with the characteristic.
So it'd be 35 then.
35 over 100, which would be 0.35.
Yeah.
Okay. It's probably just having us. Yeah, that's exactly right. The standard deviation, which is this exactly what we just did before, but with different numbers.
So standard deviation is
The square root of 0.3 times 1 minus 0.3.
0.35 that we just found.
Well, it's not p hat, right? It's just regular p. Or is it p hat?
What is regular p? Regular p is 0.3. Okay.
I'm pretty sure it was regular p for the
Yeah,
equation,
regular.
right? Oh, okay. That's what I thought. Wasn't sure. That's what I thought. But
It's
wait,
p minus what?
it's p times 1 minus p divided by n. And it's the square root of that.
Oh, it's 1 minus. And the number of samples is 100. Did you get 0.0547?
I haven't done
72? Me?
Problem is, are we using the n for
What'd you get?
0.054.
I got 0.045.
Discrepancy. So did you put 0.3 as
Yeah, I did. Equals 0.3.
minus 1?
Yeah, outside the parentheses, then 1 minus 0.3.
Yeah.
What'd you get for that? Yeah, and then you do that divided by 100. 0.21 divided by 1.
Yeah. And so I got 0.045.
That's what I had.
Uh,
4, 6 then, because we're having 3 decimal places.
what is the z-score?
How did I calculate that again?
Value minus the mean divided by c.
Yeah, the value minus the mean divided by the standard deviation. Which the value was what we got for right there. It's 0.35. And then divided by the standard deviation.
0.35 minus 3 divided by what? Standard deviation? What was the standard
The
deviation?
standard deviation we got was 0.046.
Can't round it. I didn't know that.
Oh, 0.045 then.
So I got 1.01089.
So you took 0.5 divided by the,
0.5.
it shouldn't be 0.5.
0.045
How does
for the
that
standard deviation. So what did you get?
So the z-score I got 109.
Yeah, that's what I got.
0.091. Okay, cool. What is the probability that Brittany gets at least 35. Well, what it was one.
So you just all right. Gets at least. Oh, you take. Yeah, you take that z-score, you'd put in the normal probability outlet, right, and then take everything that's bigger than it.
Mhm.
I'd imagine.
Yeah. That's what you do.
Did you get 0.13? Oh no, you do descending below it. No, you want it. You do everything above it. So that's the
Was least, yeah. So
Yeah.
it'd be above. So what did you get?
0.1376.
That's what I got.
Probably is going to need to be rounded. 0.1376.
0.138.
Yeah.
Okay.
If the true proportion of the candidate, the survey we want to determine the probability that the results of the survey would suggest the candidate is losing the election, getting less. What is the standard deviation of P? Hat. So the standard deviation is just 0.52 times. It's that thing we've been doing all day.
Then deviation P hat.
What was the sample size? It was 2,000.
That's not 0.01.
0.000125. Oh, we take the square root.
Yeah.
Then we gotta do the z-score
You,
again.
you got 0.011.
Yeah. So it'll be 0.011 minus.
What z-score would you use? So the z-score is what again?
Score is the value minus the mean of the standard deviation. So we would take the. Oh, we have to find the value. Really? I'm confused now. Yeah, I think. Yeah, we have to find. P hat, which would be the x over the n.
But do we even know the x? Is x bar? X bar is not a standard deviation.
Confused right now.
What z-score would you use? Formula for the z-score.
The z-score is the value minus the mean over the standard deviation. But what is the value?
But we know 0.52. So no 0.52, and then we also know standard deviation is 0.11 or whatever, 0.011. So we just need to figure out what the value is.
Maybe you can use, so
So the value is not 2,000.
there's an equation to,
Could be 50.5.
It could be actually.
Because that's what you're.
do it. So
Because it'd be 0.5 minus.
0.5 minus 0.52,
Or would it be the other way?
but it's the value minus.
Yeah, so maybe it's that way.
It seems like we got was 0.5.
Our z-score can be negative, though.
Yeah, that's true. You score can be negative. And you still get a positive.
And it's just 11, right?
Divided by the standard deviation, yeah.
So I got negative 1.818.
Okay. We're just gonna plug it in the probability output.
Because it's like, yeah, that's both the positive and the negative one, so that's perfectly fine.
Well, no, that would be our z-score though. First.
Well, a z-score is always not negative or positive. It's just like it's 1.8 because it's always
Yeah.
like a difference.
It's just positive, but the area is the z-score that we just got, which was what? What did you get? 1.818?
8.818,
1.818,
and then we're looking for
and then 16 is
like if he's gonna lose. So negative z-score would probably.
Wait, how'd you get 1.818?
so they're not asking us though to find.
So I got 1.79.
So you put 0.5 minus 0.52, right?
Yep.
Which gives you a negative 0.02.
Yeah.
And then you divide that by 0.011.
Yeah, but you rounded to 0.011. I didn't round them because I kept the whole long number.
And you
This is not to round.
So I just got
negative 1.79. Okay. So would we use the negative z-score then?
It could probably be negative or positive.
I don't think you're really.
Well, if what we're calculating next. But
So what are we trying to find? We're trying to find.
Actually, take it.
Well, the question was getting at less than, so it would be whatever the z-score is on this side, right? Or that's less than.
yeah, but is it less than the positive z-score? Or is it less than the negative z-score? I'm just thinking that's
You're doing
less than
positive.
Try it.
So what we're going off of his right now. Off of you.
Well, I mean, we've got the same z-score, but it's just I'm wondering if we're figuring out the proportion of it.
We aren't though.
Or the probability that will show the candidate is losing, even though the true p.
The probability is going to be the same. Way. So
Sure, the probability.
I don't think so, because
it will be.
well, if you take the negative this, or if you take it below
Oh
this.
well, yeah, but you have to do.
Oh, you have to. Yeah, that makes sense then.
Because I would go with the negative one since we got the negative z-score. But I just wonder if that means that, or like not the absolute value of it or whatever. But you could try it both ways.
Yeah.
Because because that's what we calculated the z-score for, really.
Yeah.
So I think the probability is 0.067. Yeah, 367.
0.037.
Yeah.
Would it be this? Would it be those two?
I don't know.
Here, so it really matters which one.
Yeah, but it can't be greater than. It has to be less than.
Yeah.
Because it's got to be. Yes.
So it's highlighting.
I don't know. You could,
So I guess we'll just pull it up and submit it, and if it doesn't work, then we'll change it to the other way. Show me the money. Just money. 94.4. We got one wrong.
I didn't get the z-score wrong.
Did you put negative?
Yeah,
I put negative as well. The one that I got wrong.
Oh,
was-
if p equals 1/4, what is the smallest n that satisfies the requirement?
Doesn't make any sense. I don't know.
I think it's 0.2. Maybe. I don't know. We can
It
try
doesn't
it.
make any sense though.
Well, we should just look at the chapter because I'm sure they say something about a requirement. Oh, we can apply the essential limit theory to sample proportion. I mean, could it be 10?
Why would it
Because
be 10?
has anything to do with the 1/4 thing, but it does say in the chapter we can apply essential limit theorem to sample population and include the following conditions are satisfied: NP is greater than 10, or n minus 1 minus, or n times 1 minus p is greater than 10. This doesn't give us p, does it? No, it does give us p. So we could probably figure it out using that equation.
What is the smallest?
'Cause if
n that
P is
satisfies
0.25
the requirement?
So we probably just use this equation right here. Because like these are the two things that it has to meet the requirements for it. So we take n, which n is 0.25, right? Because it's 1 divided by 4. Or no, we don't know.
No, n is 4.
Okay. Yeah. So we take 4 p, which is 0.25. I think. Just 1 minus 0.25. Okay, so that equals 3.
Interesting.
But I don't know how to like actually get it to the right number. Because it has to be greater than 10. It has to be greater than or equal to 10. Would have to. I mean, this is an algebra problem. What number would n or p? It would be 10,
It would be 10, huh?
I think.
Why?
I don't know. It doesn't make any sense.
Well, because it either has to both conditions though. So it has to be NP equal right times P.
I have a feeling that we're making it more complicated than it needs to be, but I don't know how to solve it either. So.
Well, I mean, but this is like what it says in the chapter. It's for it to be like how large is large enough we can apply the essential limit theorem to a sample proportion if both of the following conditions are satisfied. So NP, so n time or equal to 10.
Oh, wait, that makes sense. So what you're saying is n times p. So if p is 2.5 and then you just do that and you see, and you said you got 10. No, 10
But-
doesn't make any sense.
Well, okay, yeah. So it's like
Because you look it in, right? You just say, how big can I make n be? And it would still have to be at least 10 or smaller, right?
Yeah.
Well, this one says 10 or greater. This one says, yeah, you're right.
but and then both of these conditions have to be met.
Okay.
So is this something we can solve algebraically?
Well, you can, but it's just trial and error, which is retarded.
Okay. Um, if n is greater than 10 and n minus p, you can conduct a propagation in normal probability output. Okay, cool.
So
You can't just solve for x with that?
No. Equal, right?
Mhm.
If it was
But
equals this, but since it's greater than or equal to.
we could just find what equals. Like you just said equal
Yeah, you
because that's
could.
all you need it to do.
You could, but you would have to do it for both.
Yeah. Do we have a piece of paper?
Don't. Do you have a piece of paper? Yeah, this is a technological age. We don't care.
I know, that's why I don't have paper. Just make it. I don't know. It's so much easier to figure out like algebra problems by hand. I don't know why. Okay. So n times p has to equal 10.
Yeah.
And we're trying to solve for n.
So 2.5, that would be like what, 20?
What is the smallest
20
n that
times
satisfies the
2.5 is
requirement?
10?
Well, p here we already know is 0.25.
No, 20, that would be 40.5. 40 times 2.5 would be 10, right?
Well, but isn't this how we'd solve it?
Yeah.
Because
Because we already know that P is 2.5, right?
so you just
And you
divide
just divide
two.
10, and I'm pretty sure it's 40. Pretty sure it's 40.
Yeah. So
My math has been
has to at least equal 40, and then the other one is what?
It's that one. And where did you get it? It was n
minus-
times 1 minus p
Minus 0.25
equals 10 is the
equals
equation.
10. This is 0.75. N times 0.75 equals
Wait,
10.
what's 0.75?
And then you divide by 0.75.
Where are you getting 0.75 from?
Because 1 minus 0.25.
Okay. Okay, that makes sense. You following?
yeah,
Okay.
I didn't think it was this complex.
I didn't think so either.
I don't know if it is.
I honestly don't care. So let's see what that number is. So it has to be.
So that has to be 40.
Well, wait. Where did you get 13 from?
I just divided the two.
So it wouldn't be 40 though, because
Yeah,
40 is
no.
the answer for this one, but 13.
For it to work. Because it has to meet both conditions. So if it has to meet that condition, it's not going to work if it's 13 and it only this will only.
Wait. Okay, so I get that n equals 40 here, but n equals 13 here, right?
Yeah, saying in order to get this to satisfy the requirement or to satisfy this formula to equal 10, you only have to.
So does 40 equal plug in 40 for n? Does it?
It'll be greater than 10, but we're just looking for greater than or equal to the 10.
The other one is the opposite.
Greater than or equal to 10, but you're taking n times p and you're taking a different formula here.
Well, I
So-
get it, but what I'm saying is if you right here,
Yeah, we can see.
yeah,
So 40 times 0.75 should be greater than 10. And it is greater than 10 because it's 0.75 times 40.
I guess that's true.
So it satisfies the requirement of being greater than or equal to 10.
Well, let's put it in.
But if that's right, I don't know.
Right, for sure. Definitely right. Where is she? Where are you?
What's 0.25 times 40?
0.25 times. Where we
Okay.
already calculated that.
So then, yeah, that should work.
I swear I didn't think it was that complicated either, but I'll try it. I just did the whole thing all over again just now, so we'll see what happens. Moment of truth. 40. It was right.
Yeah.
I don't think it has to be that complex either, because
Well, yeah.
you just see 1/4 is 0.25. What times 0.25 equals 10?
Well, it says, but it has to.
Yeah, you just test from there.
Yeah,
Yeah,
that's
you could
true.
just plug
That's
it into
true.
the other one.
That's true.
Because if you knew it was like, because yeah, I guess the key was just 0.25. 0.7.
Yeah. Yeah, it's true. All right, 100%. Cool, guys. Cool beans. Good job.
Go team, go.
Supposed to be the other thing. Oh. Oh. Wait, that's okay. Hey Seth, could you unplug my laptop? Thank you. Thanks, appreciate it. That was fun, guys.
The real.
Let's do it again.
Wait.
Seth and I, we have to do that little portion of the project.
Uh-huh.
We're talking about just doing it combined on Wednesday. Does that work for you?
Yeah, it'll be good.
Okay, cool. So we'll plan for an hour and a half or something like that. It didn't look super complex just to do that one part.
Yeah, it's hopefully not.
All right. See you guys.
See you later.
There's some pictures yesterday.